All right, today we're tackling something huge, a force of nature so immense it literally shapes the lives of over a billion people. We're talking about India's climate and the colossal engine that drives it all, the monsoon. So let's start with the puzzle. How is it possible for one single country to be home to frozen Himalayan peaks and, at the same time, scorching hot deserts? How can it have some of the wettest places on the entire planet right alongside regions that are bone dry? It's a land of unbelievable extremes. And, yep, it's all India. I mean, just look at the numbers for a second. In the winter, a place like Dras can get down to a mind-numbing minus 45 degrees Celsius. But then fast forward to summer, and the Rajasthan desert is sizzling at 50 degrees. That's a nearly 100 degrees swing, all within the borders of one nation. And the difference is just as wild when you look at rainfall. You've got Meghalaya in the northeast, one of the wettest spots on Earth, getting soaked with over 400 centimeters of rain every year. Meanwhile, parts of western Rajasthan get less than 10. The difference is just staggering. So all of this brings us to one central question. What in the world is driving these incredible extremes? What kind of climate engine can produce such wildly different conditions? Well, the answer comes down to one single, powerful, unifying system that basically orchestrates the entire subcontinent's climate. And that system is the monsoon. Now, when we hear the word monsoon, most of us immediately think of rain, right? But that's only half the story. The term actually comes from the Arabic word mausim, which simply means season. So at its core, a monsoon isn't just rain. It's a massive seasonal reversal of wind direction. The whole atmospheric system does a complete 180. Okay, so how does this great monsoon machine actually work? What's the secret behind this colossal flip-flop of winds? Think of it like a two-step dance that happens every year. In the winter, the huge Asian landmass gets really cold, creating a high-pressure zone. This pushes cold, dry winds out from the land towards the sea. But in summer, the script completely flips. The land heats up like an oven, creating this massive low-pressure area that acts like a giant vacuum cleaner, sucking in all that moist air from the ocean. That massive inrush of what air? Well, that's the monsoon we all know. So, what are the key parts of this engine? Well, first, it's that basic difference in how land and sea heat up and cool down. Second are the huge shifts in air pressure that happen because of that. And third, and this is absolutely crucial, you've got the Himalayas. They act like a giant wall, trapping that moist air and the whole monsoon system right over the subcontinent. This powerful cycle doesn't just give you a wet and a dry season. Oh no, it's way more interesting than that. It carves the entire year up into a distinct four-part rhythm. Let's take a quick journey through them. So here's how the year breaks down. From about December to February, you've got the cold, dry winter. Then that gives way to the hot, sticky pre-monsoon summer from March to May. Then comes the main event, the advancing rainy monsoon, which lasts from June to September. And finally, things wind down with a transition period called the retreating monsoon in October and November. And now for the headliner. Around early June, those moisture-packed winds finally hit the coast. But notice how they don't just show up everywhere at once? The monsoon is a gradual wave, sweeping across the country over the course of about a month, bringing that life-giving rain with it. But here's a really important thing to get. The monsoon is not 4 months of non-stop continuous rain. It's not like turning on a faucet. It's famous for having breaks. You'll get these intense, rainy spells followed by periods with no rain at all. This kind of stop-start nature is a huge reason why it can be so unpredictable from year to year. And then, just as it arrived, it begins to leave. By early October, that monsoon engine starts to go into reverse. The low-pressure system over the north weakens, and the winds start their slow retreat. It's a process that starts up north and moves south, bringing clearer skies and a welcome drop in humidity. So we've gone through the mechanics of how it works, but what about the impact? Why does this matter so much? That brings us to our final section. How the monsoon, for all its extremes, really acts as a unifying bond for the entire subcontinent. And here's the great paradox of the monsoon. While it gives everyone a shared calendar, it definitely does not share the rain equally. The really dark blue areas you see, like the northeast and the western coast, they can get absolutely deluge, making them prone to floods. But then you look at the lighter shaded regions, like Rajasthan, and it's a completely different story of water scarcity and drought. This chart really puts those numbers into perspective. Mawsynram gets over 400 centimeters. Now compare that to Delhi with around 67 or Jodhpur, way out in the desert with just 37. It's almost hard to believe it's the exact same weather system at work, isn't it?
And yet, despite these massive differences, the monsoon creates a shared experience. This seasonal pulse, this rhythm of arrival and departure, gives the entire subcontinent a clock that everyone lives by, from a farmer in the most remote village to a tech worker in a bustling city.
As one source so perfectly puts it, the Indian landscape, its animal and plant life, its entire agricultural calendar, and the life of the people revolve around this phenomenon. From culture to crops, the whole nation is united in its waiting for and reaction to the monsoons. It's the thread that weaves the entire country together. And that leaves us with a really profound question. The monsoon is a unifier, but it's also a source of both life and destruction. It brings life-giving water, but also devastating floods and droughts. So how does a nation, how does a billion people, balance their lives around a force that is so incredibly powerful, it's so fundamentally uncertain?